When you think of a drill bit cutting away rock, you usually think of the rock being crushed and chipping apart, but that's not what's really happening downhole. Consider a bit cutter dragging along the formation. The cutter is actually scraping grains away from the rock. How could fluid loss play a role in how fast this happens? To think this through, note the different pressures downhole. There's the overburden and confining pressures of the rock, and also the pore pressure within the formation and the borehole pressure applied by the circulating drilling fluid. Going back to the bit cutter, note the shape of a PDC cutting. It's not chips of rock, it's an extruded powder of crushed rock material. It would seem that a powder material would be really weak, but it actually can be stronger than the material surrounding it through a phenomenon known as dilational hardening. Drilling overbalanced, the borehole pressure is going to exceed the pore pressure by some amount. There is another pressure to consider, the pressure inside the cutting. As the cutter extrudes granular powder, it's expanding. This expansion is going to cause a massive pressure drop within the cutting, which can make the cutting stronger than the rock surrounding until the pressure inside the cutting reaches equilibrium with the wellbore pressure. A clear fluid, such as water or brine, with almost no solids, features a high spurt loss that allows fluid to enter the cutting extremely fast. This limits the dilational hardening effect for faster drilling. The key to sustained high rate of penetration is to keep solids that might form a seal on the cutting out of the fluid by monitoring fluid loss to keep it as high as possible. Aggressive solids control measures are often utilized, such as dewatering with a flocculating polymer, fine shaker screen sizing, and high-performance centrifuges. Clear fluid drilling provides great drilling benefits in many unconventional and geothermal fluid applications because the formations have very low permeability and little to no interaction with water-based fluids. At elevated density, the cost of the brine may become an issue where a weighted drilling fluid is cost-effective.
That concludes this AES Drilling Fluids Tech Tip. Stay tuned for the next one, and if you want to learn more, have a listen to The Flowline, our podcast. And if you want to improve your drilling fluid performance, please reach out to us at AES Drilling Fluids.